To use TMT codes, enter the code at the search prompt at www.jackboard.org and you'll be taken to the page it points to. In this video, we're going to learn how to use RC servos from the JackBord, from the command line, and inside programs. In part 1, we learned how the RC servos work and how we can attach them to the JackBord. If you haven't already seen part 1, you should go and view it now. You can do so by using the TMT code shown on the screen. For this video, we assume that the RC servo connected in part 1 is currently connected to your JackBord, and that the connections look like this. Just before we start using the servo, we need to have a quick look at the idea of accessories. When you get a servo, it will come with a number of arms, which are attached to the main shaft and allow the servo to do its job. There are also some screws that are used for attaching the arms. Now that we've got the servo connected, we need to set it up. And to begin with, we actually have no idea where the shaft is currently pointing. So to fix this problem, we go to the command line, and at the command line type svp space A1 space 0 and press enter. This will set the shaft of the servo at 0 degrees. Now that we know that the shaft of the servo is at 0 degrees, we need to work out where we want to put the arm so that it's in the correct position. In our case, we want 0 degrees to point at 9 o'clock or directly to the left. So what I'm going to do now is fit the arm onto the servo's shaft so that it's pointing left. You may find on your servo that you can't get it precisely at the angle you want, and this is because of the gears that are used to attach the arm to the servo's body. Now that we've established the 0 position of the arm, and we've fitted it correctly, we need to take the smallest screw that came with the servo and screw it into the center like this. That way the servo's arm will be secure and won't come off during operation. When you're securing the servo screw, make sure that you don't screw it in too hard, otherwise you'll strip the thread and damage the servo. The SVP, or servo position command, sets the angle of the servo's shaft between 0 and 180 degrees. If I wanted to set the servo's shaft to 90 degrees, I would type SVP space A1 space 90 and press enter, and the shaft moves to 90 degrees. We use A1 because this is the pin that the servo is connected to. If I then wanted to change the angle to 180 degrees, I would type SVP space A1 space 180 and press enter, and the shaft moves to 180 degrees. And lastly, if I wanted to move the servo's shaft back to 0 degrees, I would type SVP space A1 space 0 and press enter. The next servo command is the SVS, or servo sweep command. This lets you have the servo sweep between two angles. So for example, if I wanted the servo to sweep between 0 and 45 degrees and then come back again to 0, I would type SVS space A1 space 0 space 45, and then I would put 250, which is a delay in milliseconds I want between moves. And when I run it, the servo does this. The delay provided is the delay between steps as the servo moves. A servo is a special type of motor with a shaft that you can move from 0 to 180 degrees. You can attach a servo to the JackBord using the dual servo adapter universal sensor interface, and a servo can be used with any of the pins on ports A, B and C. To control the position of the servo's shaft, we use the SVP, or servo position command, and to have it sweep through a given angle, we use the SVS, or servo sweep command. In this section, we're going to look at some demonstration programs to illustrate how servos work. You can access each program by using its TMT code. For this first demonstration program, when we run it, it will move the servo's arm from 0 to 180 degrees and back again in 10-degree steps, and it prints the values of the arm angle in the Print tab. This next demonstration is part of the RC Wi-Fi signal strength meter project, which you can find at the TMT code shown on the screen. We're going to use the JackBord as a Wi-Fi signal meter, and we're going to display the strength of the Wi-Fi signal using our RC servo. So what we've done is added some red insulation tape to the servo so that we have a better pointer. And what will happen is that the lowest Wi-Fi signal is displayed as 0 by the servo, and the maximum or the best Wi-Fi signal strength is displayed as 180 degrees. When we run the program, it will display the current signal strength of the Wi-Fi and also print it on the screen. And it also shows us the angle of the arm that it's using for a given signal strength. So as you can see here, our signal strength is about in the middle of the range, which is pretty good. Try this project at home and see how the signal of your Wi-Fi varies as you move around the house. What you will find is if the Wi-Fi signal gets too low, the JackBord will indicate that it's low, but then it will also lose the Wi-Fi signal and be disconnected. If that happens, just move back to where the signal is stronger and it will reconnect and carry on running. To learn how the code works and learn more about Wi-Fi signal strength detection, use the TMT code being displayed now. For this last project, we've used the RC servo to make a simple claw. The first part of the claw is a piece of rubber tube which connects to the end of the servo's arm. This is important because it gives us an ability to grip an object. And on the other side, we have a piece of Jackano that extends out and has a notch on the end, which is simply a triangle plate bolted on. And what this does is if you have an object like, say, a toilet roll, and you close the claw, the notch at the end stops the toilet roll from getting away if the robot moves backwards. To get the code for this program, use the TMT code shown on the screen. When we run the program, it will display 3 buttons. The first one is Open, the second one is Close, and the third one is Quit. The angle for the Open button is 0 degrees, and that's what's set now. When we click the Close button, the servo's angle is set to 60 degrees. This is so that when we put an object, in this case a toilet roll in there, and we close the claw, we don't overstress the servo. And finally, we have the Quit button. When we click this, the program exits and the servo arm opens. You can get to the simple claw project page using the TMT code shown. In the meantime, if you want any other information or are just curious, you can visit us on www.jackbord.org.